The engineering field is a wide field of creativity and innovation used to solve real-world problems. In this presentation, a highly important concept will be discussed alongside two of these technologies. Method feasible to real-world study case will be illustrated and will be deeper understanding and on the real-life connection.
Today, we are discussing the differentiation in real life for engineering problem. In this case, we are studying the rate of heat transfer. Next, the definitions of differentiations is essentially measure how something changed. In our case, we use differentiation to study the change in temperature over a distance, which are crucial for understanding heat transfer. Next, a composite wall with two layers and their thickness, thermal conductivity, and their temperature are given respectively. In this case, we can simply find the heat transfer rate Q and the temperature distribution by using differentiation. Next.
From the equation stated in the previous slide, by rearranging and applying the technique integration, we will be able to obtain an equation of temperature equals to negative heat transfer rate multiplied by x over the thermal conductivity. Substituting the values of layer 1 given in the question, we find the equation of temperature equals to temperature of hot minus Qx over K for layer 1. Similar to what we have done in slide 5, applying rearrange and integration, we get the temperature of the cold side by the equation of T equals to temperature of layer 1 minus heat transfer of layer 2 over its thermal conductivity. Proceeding to the next slide, we use the boundary conditions, finding a temperature drop across the wall, rearranging and integrating once again, and getting a result of 6000 watts as the rate of heat transfer. Coming to our equation, temperature of layer equals to temperature of hot minus rate of heat transfer of layer times x and over the thermal conductivity. We substitute the value we obtain into it and finally get a result of 130 degrees Celsius for layer 1. We go in the similar solution on layer 2 and see the temperature of coal is 50 degrees Celsius for layer 2. The slide with figure indicates a conclusion of temperature decreases as the distance or the thickness of the wall increases. While slide 10 has a graph of temperature distribution against distance or thickness of the wall to consolidate our real points.
This is the question today we want to discuss, which is aircraft flies upward with a constant velocity perpendicular to the x-axis, and the flight is detected at a0 and a is greater than 0. The missile is launched from origin 0, its initial speed is 2v. According to the above description, we find out the expression of y equal yx, the missile's flight trajectory. The second question is find the time from the launch of the missiles to the time it hits the aircraft. Before solving the problem, let's on to certain relevant formula. The first formula is x equal to vt is based on moving at a constant speed to find out the distance. Beside the length of parametric curve, use this formula, and the log formula, which is ln a minus ln b equal to ln a divided b. Now let's go through to the question. First, the coordinate of the missiles are different at different moments. Let the coordinates of the missiles at time t be p, x, y. At this time, the coordinates of the aircraft are a, b, t. Well, y coordinate is vt because its velocity is constant and distance equal velocity multiple times. The following step is eliminate parameters, and the arc length OP is equal to 2vt, and we need to define the y prime, which is equal to the gradient. After derivative both sides for x, we will get this function. Because of y is not included to the function, so assume p equal to y prime and y prime prime equal to dp dx equal to p prime. After simplify and move to according to the rule of log, we will get the function 1, the f1. After that, we substitute p initial and y prime initial equal to 0, so we can find out the figure of c1. which is square root of a. After solve simultaneous equation, we can get the expression y equal yx of the missile's flight trajectory, which is this function. When missile hit the aircraft, x equal to a, and substitute to the expression y equal yx, then we will get y equal to 2 divided 3a, and according to the formula, time equal distance divided velocity, eventually we will get the t, which is 2a divided 3v.